Hi everyone, this is Mr. Lee. Today's topic is on sequences and series, and as you can see, right, you are given over here a sigma notation, right, sum from 1 over n times n plus 2 from 1 to capital N, and you have a given result. Okay, normally what you'll be told to do, right, is to derive this formula, potentially using method of difference with partial fractions. Okay, but that's not the focus for today. Instead, we will focus on one category which is of deduction type, which is a more advanced category over here. So given this expression, given this formula, what you need to do is to find, right, the sum of a related expression 1 over n minus 1 times n minus 3. Well, instead you sum from 6 to 2 capital N. Right, so how do you tackle such questions? Well, there's actually a certain trick to it, and in fact, there's a certain sequence that you need to follow. In which case, you first need to settle the general term, make sure that they are aligned to that of the original term, and then the first term, and lastly, settle the last term. Do it one at a time, and you find that you probably won't go wrong for future questions. So the first thing to do, right, is to recognize that well, the one I highlighted in yellow, 1 over n minus 1 times n minus 3, somewhat is related to 1 over n times n plus 2. Okay, it seems like what you need to do is to just replace the n by n plus 1. Okay, but do take note over here, the corresponding ones, right, actually between n minus 1 and n plus 2. Because, I mean, the easy way to check is to look at which term is larger. N plus 2 is the larger one in the original guy. N minus 1 is the larger one, I mean, if you compare that with n minus 3. So the one that I just circled in red are the ones that correspond to each other. So in short, in order for you to make sure that they are aligned, you need to replace your n by n plus 3. Okay, so in this case, you need to replace your n by n plus 3 so that the general term, right, basically gives you back your n over here, and this is your n minus 2. Of course, if you do this replacement, you find that you need to replace the general, every single term that you have in the sigma notation. So instead of n equals to 6, it's now n plus 3 equals to 6, and then the last term is as well n plus 3 equals to 2n. So of course, if you simplify that a little bit, you find that this becomes a sum from n equals to 3 to 2n minus 3, right? If you just do the simple manipulation across the equation on top and bottom. And then, of course, as I mentioned, the general term at least is now aligned. This general term is indeed what you want, right, from the beginning. But of course, now if you notice, right, the second thing to look out for is the first term. The initial term is actually now free, but you want 1, right, which is what was given to you. So what you do is basically use properties of your sigma notation, right? Instead of summing from 3 to 2n minus 3, you sum from 1 to 2n minus 3. Of course, this gives you extra terms, namely the sum from 1 to 2. So all you need to do, very simple, is to just minus them off. Seems like it's a double work, but you find that this allows you to make use of the formula or the result given to you by the question. The only difference is now you no longer have the sum from sum to capital N. You are summing to n minus 3, and you are summing to 2 in the second term. Nothing to worry, right? All you need to do is to replace whatever n's you see, right, by the new expression over here. So in particular, right, what I mean over here is if you actually replace this n, you just have to replace the corresponding n's over here as well. So in which case, you notice that now if you look at this particular first term, this is just replacing the capital N by 2n plus 3, 2n minus 3. Similarly, the one in green, by the sum from 1 to 2, is just a matter of replacing capital N by 2 as well. Okay, then the rest is just the usual algebra. Okay, one thing to take note over here, the 3/4 cancels. Okay, and all you need to do is to simplify the rest of the terms. I think it shouldn't be that bad. Okay, you find that this simplifies nicely to eventually what you need to prove. Okay, so this is the first part of the question. The second part of the question involves deducing, right? And you find that this is somewhat same but different, right? You have the general term now as 1 over n minus 1 squared. Okay, so how do you link this 1 over n minus 1 squared to this 1 over n minus 1 n minus 3? Well, it's a matter of comparison. You just have to observe that the general term, which is 1 over n minus 1 squared, if you compare that with the given general term 1 over n minus 1 n minus 3, you'll find that the latter term, right, this guy over here, this is actually larger because the denominator here is actually smaller, and that yields a larger fraction. Okay, and this is true, right, for any n values that is at least 6, right, as given by the question. So if you sum up term by term from 6 to 2n, right, this inequality follows suit as well. And of course, what is this result? Well, we just proven it in the previous part. It's your 7 over 24 thing, right? And what you need to notice that to prove the inequality, what you need to observe is that these two terms you need to account for. And each of them, right, are positive terms. These are positive fractions. So when you subtract these positive fractions from 7 over 24, certainly, right, you find that the result is that this difference is going to be bigger, it's going to be smaller, right, than 7 over 24. And that proves the result. Okay, hope this part isn't too hard. And we'll see you next session.